Alright, welcome back to MicroStart Electronics. Whether you're a maker or a designer, engineer, creator, hobbyist, you'll run into situations where you want to take measurements. For example, this new device, it's a programmer for ARM processors. And I'm excited to try it out, but I know right away, I'm going to want to create some sort of enclosure for this thing. So before we get started, we're going to just say, we'll call this one number 1, number 2, and number 3. Number 1 is kind of the extreme. It's all electronic. It tells you exactly the numbers. So we'll go through the pros and cons of each one. So the pros first of all of them. So this one is electronic, but if I were to turn it on, which the battery's out right now, but if I were to turn it on, it would read out the inches, and it works pretty good most of the time. And it's really easy to read because you don't have to even look at this scale at all. You just pretty much read this. You can obviously check the scale with that. So that's the pro of this one, super easy to read. Then you get this one. It's a little bit more mechanical. You have a dial, and you have to be able to read the first scale. So right now, you're looking at 1 inch, and if I keep going, 1 inch, about 30 thousandths right there. So that's your thousandths place of an inch, and then it's 1 inch and 30 thousandths. So I'd say this is easier to read than this one, but maybe harder to read than the number 1. So now let's talk about number 3. Number 3 is the hardest to read, and I'm going to show you why. This one's called a Vernier calipers, and it doesn't require any batteries, and you can get pretty accurate measurements. So I'm going to show you how to use the Vernier scale. Now this one you can see on my screen is only I would say it'd be like the centimeter scale. On the calipers I was just showing you, it had both inch scale and a centimeter scale or metric scale. So I typically use the inches scale, but we're going to go use this metric scale. And this doesn't even have any units on it, so it could be any kind of scale. But you can, this simulation I will put a link to, just so that you can try it out for yourself and see how you like it. But we'll just go through how it works. So you have the main scale that you can see that's on the main part of the caliper. And if we we're at 3 centimeters right now. We're just going to call it centimeters. And we know we're past 3 centimeters because this 0 point is past it. And this would be less than 3 centimeters. So if we go past it to here, we're somewhere between 3 and 3.1. So we don't know how much we are between 3 and 3.1. So this is where the Vernier scale helps. Because if you, and I can actually display this, if you hit the virtual divisions, you can see there's all little tiny divisions, but I can't read those. Now, if you had a microscope and you had a really tiny, thin line on the 0, you could maybe see which 0 lines up with these little marks. But we don't have that, and that's not going to work. So we know that 0 it's past 3.0, but it's not 3.1. And then we also know that it's whichever one of these lines up the best is how we're going to get our reading. So right now, we have this 4 lines up best with 3.4. And so it's 3.1, 3.2, 3.3, 3.4, 3.5. So this 4 happens to line up. And so it would be 3.04. And if we check this, we'll click the display value, and you'll see 3.04. And we can do one more example. We'll drop it down to here, almost to 1 centimeter. So we know it's not 1 centimeter. It's 0.5, 0.6, 0.7, 0.8, 0.9. So it'll be 0.9 plus whatever we get on here. And this 8 lines up perfectly here. And so whichever one obviously lines up, that's the one we're going with. So it's 0.98. So if we click this thing, 0.98 centimeters. So it's a very useful scale, and it's not that hard to read if you remember how to use it. It's obviously all about, and this little tutorial simulation thing shows you that, okay, you read this one first, it's 1.5, and then you read the next one, and that's 0.08, and you just add them together, and that's how you get your values. So I'll put this in the description below, and you can kind of mess around with it, and if it's something that you think will be useful to you, you could obviously then buy one of these calipers. And there's definitely can be a quality difference in different calipers, even just these Vernier calipers. This one is a little harder to read, so that's the disadvantage of this one. But it's also the most durable, probably. I mean, I would say nothing to go wrong with it. You're not going to run out of battery, and so it's the most durable. But the disadvantage is hard to read. Now, if we go back up the line, number 2, the disadvantage of these is, okay, it's got a glass, front to protect the needle, and it's also, so that could break. It's also occasionally, when you're moving fast, and there gets dirt in these little gears, in the gears here, sometimes this needle will sometimes jump, or it won't move when it's supposed to, and you go all the way back to 0 and it won't be there. So that's one disadvantage of this one, but it's definitely, there's no batteries to go out. This one, the disadvantages are sometimes when you go fast, like if you're going like this or jerk it, it'll lose its spot. The other problem with it is that, like right now, the battery's out. Well, batteries to me are kind of like a reoccurring, cost. So I don't love electrical things that have batteries sometimes. I mean, I guess a watch battery and anything like that, or phone, but it's not rechargeable. So I'm going to throw that one out. But if you want easy reading, yeah, this one.